Welcome to Brain Vision.
Okay, so we're doing chapter 37, problem 56. So it says determine the wavelengths of the second Balmer line, which is n equals 4 to the n prime equals 2 transition. And this is shown in figure 26 if you need to look this up. Determine likewise the wavelength of the third Lyman line and the wavelength of the first Balmer line. Okay, so how do we find the wavelength from its transition? So we're going to use equation 3715 in the book. And how this does is lets us relate the wavelengths to the energy transitions of Hc. And then we can write the energies of the final line. Sorry, the initial line. So this is En minus the final level, n prime. And that's the wavelength of the photon that is either emitted or absorbed for this transition. So for part A, for the second Balmer line, which was we said right here, n equals 4 to n prime equals 2, we can look at the figure to find the energy levels. And we can write lambda as Hc, which is 1240 eV nanometers. And what is E4? E4, if we look at the Balmer line for hydrogen, that E4 is negative 0.85 electron volts. This is all in that figure 26 again, just right by the problem or as earlier in the chapter. And then we need to subtract off our E2. So what is the energy of n equals 2 line? That's negative 3.4 electron volts. So let's put that in. And now we can just calculate this, and our answer is going to come out in nanometers, which is nice and easy for us. And this is 490 nanometers. Cool. Let's move on to part B. So B says we want to use the third Lyman line. So if we look at the Lyman series and look at the third one, that is going from n equals 4 to an n prime of 1. So similarly, we can write the wavelength, and this is 1240 eV nanometers. And now E4, so the energy of the fourth level, we already said was negative 0.85 electron volts. And now the energy of the first level is negative 13.6 electron volts. So if we plug this in, we get a wavelength of 97.3 nanometers. Cool. Let's do part C now. And this is wanting us to do the first Balmer line. Okay, so the first Balmer line is the transition from n equals 3 to n equals 2. Okay, so n equals 3 to an n prime of 2. So from this, we can write our wavelength again as 1240 eV nanometers. And n equals 3 line here is given as negative 1.5. And our EV, not nanometers. And our E2 is negative 3.4 electron volts. So we can just plug that in, and we get an answer of 650 nanometers. Cool, that's it.